trouble with the graphing, the motion stories and all that. And so I tried to create something that maybe explains a little bit better. So let's see how this goes and see if it helps you. This is a story we were dealing with. I'm not going to go through reading it all. You have it. You can go back and read it. We read it in class, but this is all the information you need to complete all three graphs. And the only one I'm going to do for you is the position time graph, and then I'll set up the distance time graph. So let's go ahead and take a look at that. So I completed the data chart for you. It's just to try and help you out there. And remember, all we're dealing with is time position in this one. So these are the only two columns we have to worry about. I highlighted them there and the proper units. So then I made a copy of the graph here. I know it's not perfect, but I think it will work. And I've already plotted the first dot in red there, our little red guy down here. He's at 0, 0. Let's let that go. That may cover it up a bit, but you'll get the gist. And then we know each of these squares represents a position difference of 10 meters. And then as I go across, each square represents 15 seconds. So with that in mind, we've got our first one plotted. So I went ahead and highlighted it out. Our time is 0. Our position is 1. So now we need to go up and look. Now we need time 30 seconds, position 100 meters. So if we go back to our chart and I plot that point, it'll be the second one up here. I'm at 100 meters. And I told you every one of these is 15. So 15 and 30. This would be 30 and 1. Let me see if I can move this sucker. I guess not. We'll deal with it. So now our second one is taken care of. So we move on to the third one. This is when we talked about when we were in the restroom for 90 seconds. So now we're up to 120 seconds, but our position didn't change any. We stayed in the restroom. So that would mean in our graph, it's going to look like a straight line for 90 seconds. There's 30, 60, 90 seconds. Here's where we're at now. Our position is still 100 meters away from our starting point, but now we're 120 seconds into it. So once again, I can highlight that, take it away. And now our next part is when we were headed back. This is when we took 15 seconds to go back 50 meters towards the room. So our total distance or position is 50 meters away. So what that would look like is our next dot, 50 meters away. That's halfway down there. And we did it in 15 seconds. And so now we are 50 meters away, and our time has now been 135 seconds. Back to our table. We're going to eliminate that. This is when we stop and talk to our friend for 15 seconds, or 20 seconds, 30 seconds, sorry. 35, 65, 30 seconds. And once again, we were stopped and talking, so we're still 50 meters away. So I go back to my graph. I plot that. 15, 30 seconds. There I am. I connect the line. I end up finishing talking to him. So I'm done there. Now I hustle it back. And in 10 seconds, I go the rest of the 50 meters back to my 0 position at the classroom. And so the final graph would look like so. It follows the idea of where I started from at 0, moving my furthest distance away, 100 meters. I didn't move anywhere, so I was still 100 meters away. But then I came back 50 meters, stayed there, all the way back to the start. That's how the position graph works. All you have to do is deal with the two columns that I talked about. Now to set up the next one for you, and this will be our distance time. So now all we have to look at is the time column and the distance column. And they're all filled in for you. We just have to go in and be able to read it. What I did for you also was set up the first part here. This time we can't use the same factors because we got to be able to go up to 200 meters. And so this time every square is 10 meters, and we'll stick with 15 for every square for the seconds. And so if we go back to our first one, we know we started at 0, 0, and then in 30 seconds we went 100 meters. So there's our 100 meters at 30 seconds. That's our next plot. And there's our line. So that's the first part about that. Next, we would go And what you want to look at is 120 and 100 meters. So we aren't changing distance, we're just changing time. You can go back on your paper packet and start working these out. Go ahead and fill in the first one on displacement, or I'm sorry, position versus time. And then what I really want you working on for today is trying to do the distance time one. Remember, look at the two that you're plotting. You can refer back to this video at any time. I'll even put the PowerPoint up there with just the PowerPoint, not the video. So I hope this helps. If it does help, I'll do another one that finishes out both of them so we can make sure we know how to read these for the next time. Maybe going to put us about a day behind, but I would rather do that than not get this done. So I hope this helps. We're trying. We'll see you later, guys. Bye.